Hey, Mr. Snyder here to talk to you today a little bit about geometry and angle relationships, okay? Now, the ACT loves to put geometry problems combined with algebra problems, okay? And in fact, we've been working on solving linear equations. Well, ACT isn't going to give you just a linear equation to solve for. What they will do is kind of embed a linear equation into a geometry problem and see if you can do that through like the concepts of geometry. Okay, so in order to be successful with that, I want to talk to you today a little bit about some of those angle relationships that I recommend prior to taking the ACT. And plus, they're just good angle relationships to know just in general. Okay, the first one that we're going to look at is just supplementary angles. Okay, so you'll see here on the website that supplementary angles are the definition of it, at least, is two angles that add up to 180. Now, usually they look like this, drawn like this right here, which has an angle and another angle that combine to make a straight line, which we know that the straight line angle measures to 180 degrees. So as you move one of the angles, in order for it to be supplementary, you have to have both angles pretty much add up to 180, which is just demonstrated here with this little applet, okay? So supplementary angles is one that you definitely need to know. Another offshoot of that is the situation where you have two parallel lines. Here's an example of parallel lines here. This one, they're just two horizontal parallel lines. This one, at least, they're diagonal. Parallel lines that are cut through by a line called a transversal create, and that's this word here, create this scenario where a lot of math problems, or at least a lot of geometry problems, come from. So you'll notice here that there's a lot of little angle relationships involved, okay? So if you look at, for example, this 62, if you have an angle here and an angle here, they're gonna match up. This is called corresponding angles. I'm gonna show you that in a second. The angles on the inside of the parallel lines, but on the same side of the transversal, are called same side interior angles, and those are supplementary. You'll notice that 62 and 118, when you add them together, you get 180. And then the last angle relationship is called alternate interior angles, which is an example of this 62-degree angle and this 62-degree angle. They're both on the inside of the parallel line, but they are on alternating side of that transversal, okay? So let me just kind of break this down for you a little bit better, and let me draw you a couple of these, okay? So when you have the parallel lines cut through by a transversal, the first of those, like I said, are corresponding angles, okay? So this is an example of corresponding angles, all right? There are more corresponding angles as long as they share the same spot, as far as, like, if you look at just the intersection between the one parallel line and the transversal, as long as they share the same spot as the picture above it, those angles are always going to be the same. For example, if I drew an angle here and then down here I have that same angle, they're going to be the same. So corresponding angles are always going to be equal to each other, okay? The next one is called same side interior angles, okay? Let me give you an example of what same side interior angles look like on a picture. Same side interior, again, the name comes from being on the same side of the transversal, but for example, they are in the inside of the parallel lines, okay? So they're called same side interior angles. Now these ones are not going to be equal, okay, but they are going to add up to 180, so they are supplementary, okay? And then the last one I want to talk about, and the one that kind of confuses people sometimes, is called alternate interior angles, okay? An example of alternate interior angles are this angle and this angle, whoopsies, here, okay? Those two angles, if you remember looking back at the example a couple seconds ago, those two angles are the same. So we say that alternate interior angles are also equal, or congruent in terms of geometry speak, okay, or speech. One other angle relationship that the ACT and other tests love to use are the angles of a triangle, or the interior angle sum of a triangle, okay? That pretty much is pretty simple to remember, okay? A triangle's angles, when you add them up, okay, always add up to 180, okay? So that's something you have to remember, especially with triangles, okay? That the sum of the interior angles of a triangle is always equal to 180. Now that we've kind of reviewed some of those concepts and some of those angle relationships, let me just go quickly through a couple of example problems on how this might be shown in like a ACT scenario or a quiz scenario, okay? So let me just show you one of those examples real quick of what you might see on the ACT. Say for example we have a transversal problem, okay, and you know an expression for one of these angles. The first expression is 5x minus 10 for this angle up here, and then for this angle down here we have 2 times x plus 4, okay? And what it will ask you to do, or what people usually ask you to do, is solve for x. In order to solve for x, you have to understand which of these angle relationships we're dealing with. We are dealing with here corresponding angles. Corresponding angles are equal to each other, so we're going to set these two equations, or two expressions, equal to each other to solve for x, okay? So we got 2x plus 4 equals 5x minus 10. Now I'm going to simplify the left side by distributing this 2, so I got 2x, and then 2 times 4 is going to give me 8. Equals 5x minus 10. Now I'm going to move this 5x over by subtracting 5x from both sides. And I'm going to get negative 3x over here. At the same time, what I could do on the same line is show me moving this 8 over by subtracting both sides by 8 while I'm doing that, so it just saves me a little time. So notice these will cancel, and then this will cancel, and I'll be left with negative 10 minus 8, which is negative 18. Now I'm going to divide each side by negative 3, and I get negative 18 divided by negative 3, which will give me my answer. And the answer will be a positive 6, because a negative divided by a negative is a positive. Okay, so that's just one example of how these geometry problems work. Let me give you another example real quick, okay? The next one I want to show you is another one of those transversal problems, but this time I'm going to show you a same side interior problem. So I got 30x up here, and then down here I got 10 times x plus 2. Okay, the quantity x plus 2. And it's going to say, hey, solve for x. Now you have to understand that same side interiors don't equal each other, but they do add up to 180. So I'm going to set up an equation where this angle plus this angle equals 180. So I'm going to say 30x plus 10 times, whoopsies, the quantity x plus 2 equals 180. All right, so first of all, I'm going to simplify the left side. I got 10x and I got 10 times 2 to do. So I got 10 times 2 to do. 10x, 10 times 2 is going to be 20 equals 180. All right, so I'm going to combine like terms here. I got 30x and 10x, and that combines to be 40x when I add 30 and 10, plus 20 equals 180. Now I got to subtract 20 from both sides. And after that, I will get 180 minus 120, which gives me a whopping, I love the word whopping, 160. All right, so I got 40x equals 160. Now it's time to divide the 40 on both sides, and that will get me my answer. Okay, the answer for this is going to be 4. So x equals 4, and again these 40s will cancel by dividing both sides by 40. All right, so that's another example. Let's just do one more example with the triangle sum theorem. Okay, so here we go. So I have a triangle here. Doesn't really matter what that triangle looks like. I just know that there are 3 sides, 3 vertices, and I know the following thing about these angles. This side, or this angle, is going to be 5 times the quantity 5x minus 2. This angle is just going to be x, and then this angle is just going to be 4x. Okay, now you have to remember the interior angles of a triangle add up to 180. Okay, so I'm going to create an expression where this angle plus this angle plus this angle, actually an equation, because again there's an equal sign in there. This angle plus this angle plus this angle will equal 180. Okay, so I'm going to say 5 times x minus 2 plus x plus 4x equals 180. Okay, and I'm going to simplify a little bit now. So I'm going to distribute here. So I got 5x, which is just 5x, 5 times negative 2, which is this negative 10, plus x plus 4x. Now there's a little bit of combining like terms to do, so let's do that. So 5x plus 4x is just going to be 10x minus 10 equals 180. Okay, so I'm going to now add 10 to both sides, and I get 10x equals 190. All right, dividing each side by 10, I will then get x equals 19. Okay, because 190 divided by 10 is just 19. All right, so hopefully those examples help you a little bit. I have a worksheet with a couple of more angle relationship problems for you to try. Again, something very important for you guys to learn and remember are these angle relationships, because you'll definitely use them at least on the ACT, if not a couple other times in your life when doing home improvement problems and stuff like that. All right, well, enough for today. See you later. Yeah, bye.